Hey Algebra 1, here are the notes for 6.1. So what does inequality mean? Inequality just means two things that are unequal. So, unequal. And up to this point, we've been working with this idea of balance. So if you do something to one side, you have to do it to the other. Except now, we're going to be talking about two things that aren't quite equal. And the symbols that we use for this are these ones. We use the less than symbol. We use the greater than symbol. This one with the little line underneath is going to be less than or equal to. This one is going to be greater than or equal to. So if I give you this statement, you must be at least 42 inches tall to ride Pirate Lagoon. Basically what that's saying is your height must be greater than or equal to, because at least means we can include 42 as well. Your height must be at least 42 inches tall. So let's think about this. If I'm 50 inches tall, can I ride Pirate Lagoon? Well, is the number 50 greater than or equal to 42? Yes, it is, so I can ride Pirate Lagoon. But if I'm only 30 inches tall, 30 is not greater than or equal to 42, so I cannot ride Pirate Lagoon. So that's the idea that we're working with, is that certain numbers will work in this equation, but others won't. So let's start working with what it looks like to graph these. Well, to graph an inequality, we're going to put that number on our number line. 35 is the number I care about. Now I have to figure out what's going on around it. So am I including 35? Because it says just greater than, it means I can't include 35. So I leave my circle alone and I say any value that's greater than 35. Does the number 40, which is on this side of the number line, does it work? Well, is 40 greater than 35? Yes. So since 40 works, I can include values that are on this side of the number line. Let's check a value that's less than 35. Let's say 30. If I put 30 into my equation, is 30 greater than 35? No, 30 is not greater than 35. And since it works, or does not work, we do not include an arrow over here. So this is what it looks like to graph this inequality. Now very similarly, if I go over here, what is the only difference between these two pieces? This one does not have the line underneath. This one does have the line underneath. So the only adjustment that I have to make when graphing is instead of leaving an open circle and not including the number 35, now I have to include it. I have to say, I can equal 35, so I cover the value. I always say if I include the value, I have to cover it. I have to make sure that value is covered under what I'm graphing. Everything else remains the same. X still has to be greater than 35, so I still have to draw my arrow going greater than 35. 40 still works, 30 still does not work, so my arrow doesn't change. So how do you know when you use a closed dot versus an open dot? You'll have an open dot when something is less than or greater than, but not equal to. You will have a closed dot, make sure I know it's closed, so shade it in completely, when you have a less than or equal to, or greater than or equal to. If you need to make that into a little table so you can see when you have those, that's fine. But just remember, if the line is underneath, that's that extra shading that's happening inside. I always think about taking this line and wrapping it up inside that circle so that it's covered and colored in. All right, now that we know how to graph, we need to figure out what values make them true. And the cool thing about inequalities is that they're very similar to regular equations. The same way that I would solve this if it was an equal sign, I'm going to solve it with an inequality. So how do I get x alone? I have to subtract 5 to the other side, and I get x over here. Notice my positive 5 and my negative 5 cancel out. My sign doesn't change. I get 11 minus 5 is 6. So the values that make this true are any values greater than 6. Well, let's check that. If I plug a 7 in for x, I plug it in up here, I get 7 plus 5 is greater than 11. Is 12 greater than 11? So when I plug in 7, I get 12 is greater than 11. Is this true? Does it work? Yes. If I plug in a value less than 6, let's plug in 5. When I plug in 5 up here, I get 5 plus 5 is 10. Is 10 greater than 11? No, it's not. 10 greater than 11? No. So since this is true, my answer is correct. So the final answer that I would box is x is greater than 6. Let's check in over here. This is very similar, where I moved the 6 over just like I'm used to doing. I have an r left here. My sign comes down, and I get r is less than or equal to negative 1. Let's check some values. Let's make sure this is true. Put my line underneath so you can see what I'm doing. So what's a value less than negative 1? Negative 2 is always a good one to check. If I plug in negative 2 and I get 6 plus negative 2, 4 less than or equal to 5. Is this a true statement? Yes, so this is true. However, if I plug something in that is not true, so what's a number that's actually greater than negative 1? Let's plug in 0, because 0 is greater than negative 1. It's not less than negative 1. I get 6 plus 0 is less than 5. 6 less than or equal to 5? No. So I know that this equation is true, and it works. Now, the difference between these two is what happens when you check the value itself. If I plug in exactly 6 over in my first example, I get 6 plus 5 greater than 11. Is 11 greater than 11? No, they're equal to each other, but something can't be greater than itself. So this is not true, and that's why we don't have the line underneath our inequality symbol. Whereas over here, when I plug in the value negative 1, I get 6 minus 1, which is 5. 5 is less than or equal to 5. Well, yes, 5 is equal to 5. So this is a true statement. So because I can do this, I have to include my line underneath. Whereas over here, I do not have the or equal to sign. That's the major difference between these two signs, is one includes the value, one does not. If you have any questions, let me know.